Yep. They'll let you know shortly.
I hope I get in, otherwise I'm screwed.
All right, guys. Let's look up here. So we want to write each interval in interval notation. Now, we don't necessarily have to graph, but sometimes it helps us if we graph it to be able to go to interval, because it's sometimes easier to see it graphically than it is to just see the inequality. So -2 is less than or equal to x is less than or equal to 3. Well, we do have two endpoints, and our endpoints are -2 and 3. So we'd have two circles, one at -2 and one at 3.
They're equal to, so is that shaded?
Yes, since they are equal to, we would shade. So we're saying whatever value x is, it can be any of the numbers between -2 and 3, and we'll include -2 and 3. Now, since x is in the middle, we shade in the middle. Questions on this here? Now, it asks for the interval notation. So we drew the graph of it, but the interval notation is our one with parentheses and brackets. And whenever we do interval notation, we need the endpoints. And for us here, the endpoints are -2 and 3. Now, -2, will it have a parenthesis or bracket next to it? Bracket. Because bracket is included, parenthesis is not. So we'd have a bracket. How about 3? Bracket. Because since they're both included, they would both have brackets. Questions on this here? We ready for the next one? X is greater than -1. So we don't necessarily have to draw the graph, but sometimes it is helpful to have the graph. Now for B, how many endpoints do we have? One, technically 2, but 1 really. Because our one endpoint is? -1. Thank you. Yep. Because what is our other endpoint? So we have x is what? Greater than -1, yes? So it starts at -1. Where is it going to? So it's going to the right. So essentially it is going to infinity, yes? So the other endpoint is technically infinity. Now graphically we don't put a mark for infinity, we just shade to the arrow. Now for our interval, we put -1 and positive infinity, or just infinity. So infinity would have a parenthesis because we can never get to infinity. So infinity or negative infinity will always have a parenthesis. Now is -1 included? No. It's not shaded in, it's not included, so it would be a parenthesis. Because when we look at our inequality sign, if it doesn't have the equal to, it's going to be an open circle or just a parenthesis. Question on either one of these here? Let's look at the next one. This one here gave us the graph already. So we do have two endpoints, -3 and 4. We can list them first. Since the -3, the dot is shaded, we'd have a bracket. Since the 4's point is an open circle, it is a parenthesis. So we would have the 3. Now, since it's going smaller,
Negative x, or negative infinity. Yep.
negative infinity, because we're going from 3 to negative infinity. Parentheses. Because since the 3 is included, we would have a bracket. And since infinity is never included, it has a parenthesis. Questions on these so far? We ready for the next bit? Set builder notation. So set builder notation uses symbols to define a set in terms of the properties of the members of the set. All right, guys. Now, the reason we use set builder notation is when listing out the numbers or members of the set is not easy or practical. So as we had the other day, if we were talking about all the numbers greater than 20, all the integers greater than 20, so we could say 21, 22, 23, and that is practical. We can list them all out that way. We have a pattern. It works. If we're talking about the whole numbers between 0 and 4, or 0 through 4, I can list those out. But if we start talking about all the real numbers, so fraction, decimal, irrational, all of them between negative 100 and 100, well, that's not practical. There's too many for us to write out. And that's where set builder comes into play. Now, the set builder has 3 main parts. Triangle, line, and circle. Now, the triangle and circle are taking the place of that part. Now, the triangle, what goes in its place is the group. What type of group or what type of numbers are we talking about? Are we talking about natural numbers, whole numbers, integer, rational, irrational, real numbers? What group of numbers are we talking about? That's the first part of the statement. What type of numbers are we talking about? Now, the bar is such that. Such that, and the last part, our circle, is the description. So the first part is what type of numbers? We define our number group such that we give them a specific definition. So it could be the set of all real numbers x such that x is less than 2. So the first part is our group, our type of numbers that we have. The bar in the middle is always going to be such that. That never changes. And then we give a description, further defining the group of numbers. So we're going to look at some examples of this here and then do some more with it. So the first one, brace x bar. Brace x. When x is just by itself, it is the set of all real numbers. It is understood to be the set of all real numbers. So brace x bar is saying the set of all real numbers x such that, what? Less than a. And that's it. So this here says that for the set of all real numbers x, such that x is less than a. That's it. Now graphically, we have wherever a is on the number line. And it'd be all the numbers to the left of it. That's all it's saying. Questions on this so far? Well, let's look at the next one. So again, brace x here, brace x. All that's saying is the set of all real numbers x, such that what? X is not equal to 3. So what is that? All right. So it could be 4. It could be 7. It could be pi. .2. Could be anything else, but it can't be 3. Now, graphically, we just make a point at 3 and just shade everywhere else. Just don't shade the 3.
Oh, wait,
Too late. Questions on these so far? We ready for the next one? So again, we have brace x bars, which is telling us the set of all real numbers x such that what? X less than x is less than or equal to 6. So it gave us the description of our number type such that our description. So on a number line, we'd have -4, and we would have 6. The 4 is not included, so it's an open circle. The 6 would be shaded. And then where do we shade on the number line? In the middle. Any questions before we look at the E? So that's our new symbol of the day. This here is element. And we're saying X is an element of, and we can name a different number type. So we could say X is an element of the integers. Because we had our different ones now, there isn't technically one for the whole numbers, but we could use the W with an extra line. And we're just saying X is an element of the integers such that X is greater than or equal to -9. So we can name a different number group. So we could have said that X is an element of the rational numbers such that X is greater than or equal to -9. We could use any of these here. Questions on these here? We can. It's not the nicest one to graph because we would have -9. We'd put a circle and fill it in. But unfortunately, everything between -9 and -8 is not an integer. That'd be part of the rational and irrational numbers. So we'd have to leave it blank. So then we would go to 8, make a circle and fill it in. And we'd have -7 with a circle and fill it in. And we'd have to keep going like this here. So realistically, graphing this one's impractical because you just keep doing that. There wouldn't be a full shade on it. And the same thing's true for the last one. Because it reads as the set of all real numbers x such that x is even. And then we'd have all the even numbers. So it'd be similar to the one above where we just have the points and nothing in between. Questions on this here? Are you ready for the next part of this? All right, they want us to sketch the graph of each set of numbers. Mm-hmm. So what's interesting with this here is really, this. Oh, thank you. All right, there we go. Because really, if I told you to graph this, it's the same as this here. So they're going to be the same thing. We're graphing the same piece. So as we were saying, our 2 points are at what? 2 and 5. 1, both, or neither of these shaded?
5 is shaded.
Shaded 5 because it has the equal to. And since x is in the middle, we in between. And that's it. Questions on this here? Are you ready for the next one? For all real numbers x, such that x is less than or equal to 0 or x is greater than 4. So we have how many endpoints? Because we have 0, yes? So it have a circle. And we also have the 4. So we have the 0 and the 4. So at 0, x is less than or equal to 0. We would shade in 0 because of the equal to. We would not shade in the 4 because it is not equal to. 0 on the number line, would we shade to the left of it or to the right? To the left because x is less than it, less than or equal to it.
So it looks like you can just go whichever way.
Normally, yes. Or x is greater than 4, so we would shade to the right. Because if x is on the left, you can shade the direction of the arrow. All right, guys. All right, guys. Focus in here. Sketch the graph of the set of numbers for all real numbers x such that x is less than -2 or x is greater than 0. So what are our 2 points?
2 and 0.
-2 and 0. So it is not. 0 is neither positive nor negative. So at -2, are we going to shade to the left or to the right?
To the left.
To the left. 0, we shade to the right because x is greater than 0.
Got one right, Dave.
And that's it. Questions on this here? Do we need to see another example of graphing number lines?
No, I think I can.
Okay.
4 and 5, but
Yeah. So
you want us to do 4 and 5 there?
we'll move on because I do put more example problems and just so if we need them, we have them. But if we don't, we feel good at a certain point, we'll move on.
For everybody. Well, just so there's not dedicated, I can't look.
All right, guys, let's focus in here. So now for these next few, we're going to write in set builder notation. So we're going to look at our first one here, the set of all integers greater than 5. Well, they told us our set, our type of numbers are of all integers. So we're talking about integers. And our description is that they are greater than 5. So when we write this in set builder notation, the first thing we're going to do is put our brace. X. Now, if they'd have said it was the set of all real numbers, we can move on, put the bar, and keep going, because brace X bar is the set of all real numbers. Now, if we're talking about integers, there's different ways we can do it, but one of them is we put our E. So I'll show us this way here. So E and then we put our symbol for integers, such that x is an element of the integers. X, our numbers, our values of x are a part of the integers, they're elements of the integers, such that, well, our description was what? It has to be greater than 5. Well, we're going to write this as an inequality, so it'd be what? X is greater than 5. So we just include that here. X is greater than 5.
The symbol for integers is that C.
Yes.
The E is
Element.
element.
It's a part of the integers. Our numbers, our values of x are going to be integers.
So bracket X,
E.
bracket X E is of all integers.
So the set, yeah, bracket x, e, and that z is, yeah. So x is an integer. X is an element of the integers, such that x is greater than 5. Questions? Yeah. So, I mean, if it just said that the set of all real numbers, x is greater than 5, we don't need this if we're talking about real numbers.
So this is only for integers.
If it's integers, natural numbers, rational, irrational, anything besides real, we have to include that. Now, it's understood, yeah. Yep. Now, we could write this as, the book will do it this way, brace x bar. So the set of all real numbers x, such that x is an do you not? Because I haven't looked into seeing who did set builder notation, but there's probably several. Not much. Upper level mathematics, pure mathematics, would be the job for this. You'd have to ask the Oklahoma Board of Education. Well, your way to fight them is voting. Yep. So this is another way, so guys, let's focus back in. This is another way that we could do this. Brace x bar, x is an integer, and x is greater than 5. Now either one of these work. So you can do it either way. Questions on this here? We're ready to look at the next one. Negative infinity, comma negative 1, or negative 1 to infinity. So we write this as in set builder notation. We have brace x. Now, did it tell us what type of numbers?
Infinity. Oh, integers.
So it didn't tell us integers, it didn't tell us natural, it didn't tell us whole, it didn't tell us any of that, right? Nope. So this one's different. So this is all real numbers. If it does not specify, it's understood to be all real numbers.
So we don't need to put the all.
Nope. Brace x, because this is understood to be the set of all real numbers x, such that now we need to give the description. And they gave us the description here in two parts. We have our negative 1 to infinity, and we have negative, so we have in negative infinity to negative 1, or negative 1 to infinity. We have these two statements. And as much as it would, or as nice as it would be to be able to just put that right in there, we can't write set builder notation in interval, or we can't write set builder in interval notation. We need these both as inequalities. So we need to rewrite it as an inequality. So with our greater than, less than, greater than or equal to, or less than or equal to. So here, our endpoint is negative 1. Now with inequalities, we will not have infinity or negative infinity. So we'd have x. Now since we have two separate statements, we'll have x twice. So for this here, we're saying that negative 1 is what? We're going from negative 1 to?
Negative 1 is greater than.
So the inequality sign would go towards the negative 1. X is less than negative 1. So the first part of our statement, which goes here, is x is less than, because graphically, if we drew this,
Put the 1 first.
we could, but we normally put x first, because at negative 1, we'd have an open circle, and then we would shade to the,
But you want the arrow to be 1 where you're going to be.
I mean, negative 1 is less than, or negative 1 is greater than x is true, because x is less than negative 1 is the same statement. Mhm. Questions on this so far?
So we repeat the same thing.
Mhm. Now for the second one, we have negative 1 to infinity. Our main endpoint of this is negative 1. Now since we do have a new statement, we would also need x. Now is x going to be greater than or less than?
Less than, or wait, no, greater than.
It's positive and we're going to infinity, so x is going to be greater than. And the only thing we're missing is the or in the middle. Questions on this here? Because the first thing we had to do is change both of these from interval notation to an inequality. Because negative 1 to infinity is x is less than negative 1. Negative 1 to positive infinity, x is greater than negative 1. So our negative infinity to negative 1 goes that x is less than negative 1. Negative 1 to positive infinity, x is greater. And then we merge them into one statement. Questions on this here? We ready to look at the next one? So we want to write this next one in set builder notation. So we have parentheses, negative infinity, comma, negative 1 bracket, or parentheses 1, comma, infinity, parentheses. Now again, with any interval notation, or if it's not directly stated, the set of numbers or the group of numbers is understood to be all real numbers. So we can do brace x bar. So we have the set of all real numbers x such that now we need to describe those numbers. So what we have to do is rewrite these two intervals as inequalities.
So it would be negative, or it would be x is less than negative 1. And then it would be x is greater than 1.
Almost. Because the first statement, we would have x, we'd have negative 1, we would have our symbol, or x is greater than 1. This is almost completely correct. There's one thing we're missing. Because if we look back at our statement,
Oh, there's a bracket and oh, yeah.
because our bracket means that it is included. So for our first statement, negative infinity to negative 1, because there's that bracket there, it's saying that x is less than or equal to negative 1. Mm-hmm. Yep. Otherwise, that's right. Yep. Less than or equal to. Yep. Questions on number 6? We feel good with this here. Kind of, sort of. Let's look at number 7. The set of all integers except -4. What group of numbers are we talking about? All integers. Well, so we'd have brace x. Well, we could go brace x bar and then describe or write out that they are integers. Yes. So we can say x is an element of the integers, such that, because since it told us a different group besides real, we have to use this here. Now, if it had said the set of all real numbers except -4, we can do brace x bar. So we're saying it could be anything except -4, yes? So x cannot equal what? And that's it. Questions on this here? Questions on anything so far? We're ready for the last two. Writing subsets and set notation. So the first thing we're going to look at is this one here. The whole numbers 50 through 54. So what are our whole numbers 50 through 50? So 52 would be 1. What else? 51. Yes, 51. 53. Almost. We're missing 2. 50 and 54. Because 50 through 54. That's all of them, yes? Is it, I mean, we could write that, yes. Because I can write out 50, 51, 52, 53, 54. We could write all that out. We don't have to use set builder notation because we can do that. Or if it has a set pattern, all we got to do is set the pattern up and then use our ... And we have them all listed.
So 50, 51, 52, ...
Yeah, so if we were saying the whole number is greater than 50, so the whole number is greater than 50 would be 50, 51, 52, 53, and that would be the whole number is greater than 50, because we can list it out and we have a pattern. Yeah, so we would just have, you're right, so it wouldn't be greater than 50, we would just start with 51. Yep, thank you. That was a good catch. Yep, that would just be 51, 52, 53, and just going on. So any questions on this here?
Literally just list the numbers.
Yep. We're ready for the next one.
Oh, yeah, I can list numbers.
The real numbers, 0 through 4. So what's our first number for this list here?
0.
What's the next one?
1.
Well, we're talking real numbers, right?
Oh.
So
0.0.
and then we have 0.127, 139, because the real numbers, there's all the numbers between 0 and 1, yes? So is it really possible for us to list all the numbers from 0 to 4, or 0 through 4? So that's where we go back to set builder. Because any group of numbers, especially real numbers that are not easily listed, we use set builder. Because we do brace x bar, the set of all real numbers x, such that 0 is what? Less than or equal to? X is less than or equal to 4. We're just rewriting 0 through 4 as an inequality. No.
Because X would just be like
Because the number of numbers between 0 and 1, let alone 0 and 4, is infinite.
Wait, so you're telling me the numbers between 0 and infinite are even more?
Well, yes, or 0 and 1. Because what we could do is if you put 1 over all of our positive numbers, because 1 over 1 would be 1, then we'd have 1 over 2, 1 over 3, 1 over 4, continuing on. All of those would be between 0 and 1.
Oh, I didn't think about that.
Yeah.
And then just keep going.
Because also then 2 and beyond. And then we could do 2 over 3, 2 over 4, 2 over 5, then we'd have 3 over. So that means,
Thankfully, by now I'm hungry. You can just like, I'm still hungry.
questions on this here? That's it. Homework is,
You said the 8th word?
yes.
The 5. This one is one of
5 through 14.
Now, yep, so on the last page of your notes is the homework page. So I put the page number just in case you're having to use the PDF of the book, the digital book.
Oh, there's
7.
So 5 through 14.
17 to 24.
Mm-hmm.
And then 26 to 27.
Yes. So 5 and 6, use braces to lift the elements. So you're just lifting them out like kind of what we did with whole numbers on the last one. 7 through 16, interval notation. So that's our parentheses or brackets. We're writing the interval.
We learned all this today, right?
So yes, because 5 and 6 we did cover some of it yesterday. 17 through 20, sketch the graph. So you're going to draw a line, sketch the graph. We did that today. 21 through 24, write the set of numbers in set builder. And 26 and 27 are the same.
not much of this word.
Point of problem.
You are doing this. You're getting a 0. Your first